Okay, so in this last video of examples, we're actually going to do two. So we'll start with this one. So go ahead and show conclusion, and let's just look at what the argument is. So we have a negated conditional, which says it's not the case that P arrow Q, and we have a conditional whose antecedent is negation Q and whose consequent is Z. So we're saying if these two things are true, then Z is true. Okay, so let's go ahead and set this up. We'll say, oh, well, and the key thing there is we notice, okay, here's the negated premise, the negated conditional, and we remember we're going to try to probably get the unnegation for contradiction with ID. So we're going to say show the conclusion, and we're going to make our assumption, and we'll stick in our premises. So we want to see if we can make any rule applications, and in this case we can actually. We can't use 3, but 2 and 4 we can put together with MT, and we'll get not Q. Good. So we've used 4, and now the derivation is stuck, and so now we do want to do a subderivation, and we want to do a subderivation that will let us complete the derivation, a subderivation that will let us complete the derivation. Well, if we had a contradiction, we could complete the derivation with ID, and on line 3 we have a negated conditional, so if we get the conditional P arrow Q, then we will be able to apply ID. So we'll go ahead and say show if P then Q. And what do we need to box and cancel if P then Q? Well, we need Q. If we need the consequent is Q. If we have Q, we can apply CD, that's what we need for CD. Well, we can get to Q because we can apply double negation to line 5, eliminate the double negations, that gives us Q, and we can apply CD to line 7. And so this is just doing the same thing that we saw in the previous problem, where you get the conditional in a funny way. It's actually enough to just get the consequent. And when you have the consequent, you can apply CD. Now in this case, this is a little bit of a bigger derivation because we're not just given the consequent of the conditional. We have to get to it by first applying MT and then double negation. But having done that, we get the consequent of the conditional that we want. And now we have a contradiction between 3 and 6, and we apply ID, and our derivation is done. Okay, let's look at our last problem. So in this case, our conclusion is just R, and we've got 3 premises. We have this negated conjunction, and we have 2 conditionals. So probably, we're going to want to be, the way we use this negated premise, probably we're going to want to end up getting the unnegation, getting P into Q, and then applying ID. So we don't know that, but that's likely. So let's go ahead and get our derivation going with our indirect assumption, not a conditional assumption, and we always want an assumption. And we'll bring in our premises. And again, we want to see, can we make any inference rule applications? And we can, because we can use not R with 4, applying modus tone MT to lines 2 and 4. And we can also apply MT to lines 2 and 5. And now we have not P and not Q. Looks good. We've used lines 4 and 5. Not going to use those again. And indeed, the derivation, well, okay, so now what do we want to do? Well, we want to think, well, it's not obvious what we should do, so we might do a subderivation, but we don't know that the derivation is stuck yet. It's not obvious. Maybe the derivation is stuck, maybe we're stuck, okay? So when we look at line 3, we think, well, we haven't used line 3, but we see that line 3 is the negation. It's the negation of a conjunction. So we think, well, if we got the conjunction, then we could apply ID and we would be done. So can we get to the conjunction? Well, what do we need? Well, we need P and Q, and if we have both of those, we can put them together with a join and form the conjunction. Do we have P and Q? No. But can we get P and Q? Yes, because we can apply double negation to 6, double negation to 7, that gives us P on line 8, Q on line 9, and now we can put those together with a join. We have P and Q, and now we have a contradiction between lines 10 and 3, and we have our indirect derivation. So the little bit, sort of tricky little bit here is we make our assumption, or we make our show line, we make our assumption, we bring in the premises, we look for rule applications, and we get to line 7. At line 7, we think, okay, what am I going to do now? There's not an obvious rule application to make. There's no particular reason why we should necessarily double negate, eliminate 6 and 7, just as a general thing. So what we need to do is look back at the previous lines, and we think, oh, here's this negated conjunction on line 3, and we think, well, how do we use this? Well, I can't apply any inference rules to it, but if I have the right thing, I can do ID with it. And what's the right thing? The right thing is P and Q. So then we ask ourselves, oh, okay, could I get P into Q? And it's at that point we think, oh, yes, we can by continuing to use our inference rules. So we don't know, when we get to line 7, right, we don't know if the derivation is stuck, or if we're stuck. We have to go back and look and see what else is going on in the derivation, what other resources we have. And it's by seeing, oh, here's this negated conjunction, that we think, aha, oh, I know what to do with that. I try to get the conjunction for ID, and then we think, oh, okay, well, I can get the conjunction. If we hadn't been able to go through that line of reasoning, in this case, we wouldn't have been able to complete the derivation. In other cases, we would have had to say, oh, there's nothing like that. Okay, then the derivation is stuck, and so instead I need to do a subderivation. But in this case, we didn't, because we were able to build P and Q with what we had right here. So there it is. That's the 4th example of how to approach a problem with a negated premise. The general idea is use it for ID, so then you have to figure out how to get the unnegation. Sometimes it's easier, sometimes it's harder, sometimes it takes more work to get to the unnegation, sometimes it takes less. But once you get it, then you can apply ID and you complete the derivation. So you're now ready to go and do the homework. If you have any questions, please let me know.